Today we are going to have about 15-20 minutes left to go over our notes. So this warm-up was just to get you guys thinking about your 30, 60, 90, your 45, 45, 90s. We're going to use them on the other page. So take your time, fill those out, and you guys can check that on your stuff. So now, on to the next page. Here is what we need to talk about today, and these are called our sum and difference identities. You need to memorize these. So I would definitely put them on your gold sheet right now. So take a second, pause the video, put them on your gold sheet. Okay, so now that you got these on your gold sheet, what are you going to do? Well, there was a reason why we had you review your 30, 60, 90, your 45, 45, 90 degree angles. So I'm just going to write down 0, 30, 45, and 60 degrees. And I might write down like 60, 90, 120. Notice I'm doing multiples, 90, what would come here, 135, 180. You guys get the idea that you could work your way around and you have all of these degree measures you know something about. So now if we get an odd number, that's our argument. Do you see that technically the 75 is our argument? We don't have a 75 degrees that we know. So what we're going to do is we're going to break that 75 up into two parts. And when we break it into two parts, we're going to use the numbers that we've used before. So I'm going to use yellow right now to highlight. I saw right away to make 75, I could rewrite it as a 30 plus a 45. So this is going to become cosine of 30 plus 45. Okay, so now what happens if you have things added in the argument? We follow our new formula. And our new formula is going to say cosine of the first one, so cosine of 30, times the cosine of the second one, 45, minus the sine of the first one, 30, times the sine of the second one, which is 45. So now, and if you need to remind yourself, I'm going to put these in other colors up here. Here is a 30 degree angle. That means the opposite is 1, the adjacent is root 3, the hypotenuse is 2. When I do a cosine, that's going to be a root 3 over 2 times 45. I'm going to put that in another angle. 45 is 1 root 2. Do you guys get why you did your opener? Cosine would be 1 over root 2. And then we're going to have our subtract sign. And the sine of 30 degrees is opposite over hypotenuse, 1/2. And the sine of 45 degrees is 1 over root 2. So now we got to go back to algebra class from first semester. This becomes 3 over 2 roots of 2. Subtract 1 over 2 roots of 2. And that's going to give me 2 over 2 roots of 2. And I wish I was done, but can you see that these reduce? And my final answer is going to be 1 over root 2. So that's basically sum and difference identities, kind of how they work, what we're going to do. So now I have cosine of 7 pi over 12. So in my head, I'm thinking, I know pi over 3, I know pi over 4, and I also know pi over 6, and just to make sure I know that pi is over 2. Now, I need this to be over 12. So in my head, I'm thinking, oh, this is 4 pi over 12. And this is 3 pi over 12. I don't have to go any further. Can you guys see that this would give me 7 pi over 12? So I'm going to rewrite this as the cosine of 7 pi over 12, which, is going to be the cosine of 4 pi over 12 plus 3 pi over 12, which I really wouldn't write it normally that way, but I wanted you to see where it was coming from, which is the cosine of pi over 3 plus pi over 4. Oh, it's a sum formula. So look up here. I see right here is addition. So I'm going to use that formula again. So it's the cosine of A. So I'm going to have the cosine of pi over 3 times the cosine of pi over 4, subtract the sine of pi over 3 times the sine of pi over 4. Okay, so over 3 is a 60-degree angle. That's root 3 for the opposite, 1 for the adjacent, 2 for the hypotenuse. So my cosine would be 1 over 2 times. Okay, pi over 4. That's 45, 45, 90, 1, 1, root 2. So I'm going to have 1 over root 2. And then I'm going to subtract my sine at pi over 3 would be root 3 over 2. And the sine at pi over 4 would be 1 over root 2. Put it all together, and I get 1 over 2 roots of 2. Subtract root 3 over 2 roots of 2. And you could leave it like that. I think I'm probably going to write it 1 minus root 3 over 2 roots of 2. I made it one big fraction. Okay, so that's one thing that we can do. The next thing it asks me to do is that I can do some identities with this. So it says verify that cosine of theta minus 90 is sine. So we're going to take our new identity and we're actually just going to work it out. So this becomes cosine theta cosine 90 subtract sine of theta sine of 90. Okay, so 90 degrees for sines and cosines. Cosine gives me a 0. So this is going to be 0 times, this one was 0. 0 times cosine theta. Guess what? That whole term is just going to go away. It becomes 0, subtract. Now, sine of theta stays sine of theta. Can't change it. What is sine at 90 degrees? Sine is 1. Okay, so I have 0 subtract sine of theta times 1. I end up with a negative sine theta. So I think that there was a typo in this one. And I'm going to just say this is kind of a bad question, and I have to apologize. I probably should have worked this one out before we did it, or looked at my notes before I did it. That one's kind of icky. So that is not correct. Oh, yeah, it is. When it's minus, Mrs. Kendall, be silly. Do you see it? This is a plus sign. So let's come back here. I was wrong. This is a plus sign. 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 Guess what? Sine of theta equals sine of theta, and I win! I knew I didn't have a typo. I was bad. Okay, so on to the last page. So with this last page, here's our things. We need to make sure we're watching. I just demonstrated that I need to make sure that I'm watching. Now, these are sine double or sum and difference formulas. Notice for the sine, they're the same. If it's a subtract, it's a subtract. But notice here's an A and here's a cosine B. So we've got to be real careful with our formulas. But we're basically going to do the exact same thing that we did. We've got to figure out something for 5 pi over 12. So again, I have pi's over 3. I have, which would be 4 pi over 12. I have pi's over 4, which would be 3 pi over 12. I have pi over 6, which would be 2 pi over 12. And I'm going to stop because what did I see? 3 and 2 make 5. Okay, so what am I going to do? I rewrite the problem as 3 pi over 12 plus 2 pi over 12. That's 5 pi over 12, which now I'm going to rewrite as sine of pi over 4 added on to pi over 6. Now, be careful. This is a plus sign here. We're using this top formula. So all we're going to do is write it out. Sine at pi over 4 times cosine at pi over 6 is going to be added to the cosine of pi over 4 times the sine of pi over 6. So now, pi over 4, 1 root 2. Sine, 1 over root 2. Cosine, 1 over root 2. For pi over 6, pi over 6 means it's a 30-degree angle. Opposite is 1, adjacent is root 3, hypotenuse is 2. Cosine, root 3 over 2. Sine, 1 over 2. We're adding those together. So I end up with square root of 3 over 2 roots of 2, added on to 1 over 2 roots of 2, which I'm going to simplify to root 3 plus 1, all divided by 2 roots of 2. Okay, so finally, we get some numbers again. These are bigger numbers. So I'm after 255. So again, you've got your 30, your 60, your 45, and your 90-degree angle. Looking for two numbers that can get me to 255. So I have, this is 60, 90, 120, 150, 180, 210, 230. 60, now notice it has a 5 in it. I'm going to need something with the 45. So 90, 135, 180, 225, and wait, I can see one possibility now. 225 and 30 would make a 255. Got it. So sine of 255 equals sine of, oops, didn't mean to put the parenthesis around that. Don't want you to get goofy with that. The sine of 30 plus 255. Okay, so with that, we're going to do the sine of 30, the cosine of 255. I'm sorry, 225. I think I've said the wrong number, and I wrote the wrong number here. 225. Oops. 221. Let's start again. Sine of 30 times the cosine of 225 added on to the cosine of 30 times the sine of 225. Okay, so sine of 30, 30-degree angle, 1 root 3, 2. So we know that the sine is 1/2 and the cosine is root 3 over 2. So what about at 225? At 225, oops, I want it to be in green. At 225, I am in quadrant number 3. That's a 45-degree angle. That has sides of 1, 1, and root 2. But remember, super, trig, class. We've got to be careful what's positive and negative here. So cosine would be 1 over root 2, but it's negative. Sine would be 1 over root 2, but it's negative. And there's a plus sign in between. So I end up with negative 1 over 2 roots of 2, subtract root 3 over 2 roots of 2, which my final answer is negative 1 subtract root 3 over 2 roots of 2. And finally, it asks us to verify this. So let's see if I can use the right pattern this time. So we're going to go back up to the top of the page and just look at it. It has a subtract sign on it. So notice they're the same, but I got to do my sine and cosine. So help me make sure that I do that. Ask a question if you want to. So sine of theta times cosine of 90, subtract cosine of theta times the sine at 90. Okay, so sine of theta is just going to stay there. Cosine at 90 degrees, 0. Subtract cosine of theta. Sine at 90 degrees is 1, and I'm left with negative cosine of theta equals negative cosine of theta, and I win! Okay, guys, try your homework. Monday, we will go over it, and we will continue to talk about these things. Good luck, everybody.